This is Greg Troutwine with Offshore Engineer TV, and we're here again with Philip Lewis, Director of Research for Intelatus, to discuss the emerging and prospects of the offshore floating wind market. So, Phil, to start us off, a lot is spoken about floating wind, but can you just give us some of the high-level numbers just to give a size and a shape to the emerging market?
Sure, Greg. No, thanks, and good to be back. Well, yeah, it is a market that's talked about a lot at the moment, a lot of excitement about there. But I think we do need to understand it a bit better, and that's why we spend a bit of time really drilling down into it to get the numbers and sort of. So what you've asked is, what are the numbers? So, I mean, it's small today. I mean, you're only talking 200 megawatts at the end of 2020. And to put that in context, global offshore wind capacity was around 60 gigawatts, or 60,000 megawatts at the end of 2020. So floating wind is starting from a comparatively very, very small base. We forecast that that the capacity for, grid connection of floating wind will reach about 61 gigawatts by 2035. So it'll reach the level in 2035 that the bottom fixed market reached at the end of 2030, but it'll do that in a much quicker time. What that translates to in terms of spend, you're talking about global capex of over $250 billion through 2035 in floating wind farms for the supply chain. There's the bit that we're particularly interested in, which is the supply chains and the floating installation market, which we go into in our report on installation vessels we just put out. And this ranges for a vessel owner and contractor from a pure T&I scope, transportation installation, to the full EPCI, engineering, procurement, construction, installation scope of works, amounting to, our forecast is 28 billion to 145 billion. That's a range depending on the low T&I scope to the full EPCI scope in the full forecast period. So for contractors, there's actually a quite significant opportunity.
You mentioned vessels and installation. What specifically is the big difference with floating wind as opposed to bottom fixed wind?
Okay, so I think there are many differences and similarities, but maybe let's just try and boil it down to three big ones that sort of drive things. Is the ability to maintain stations. So keep your turbine where it is, because don't forget it's sitting on a floating structure this time, not bottom fixed like the picture behind you. And there's moving the turbine, and thirdly, there's the dynamic inter-array cables. So how do you maintain that station when you're at sea, the position? It's a combination of anchors and mooring chain. So basically, those who are familiar with the oil and gas industry will go, okay, yeah, we understand moorings, we understand anchors, we understand mooring chain and ropes and wires. Yes, we believe the quantities and sizes involved are significantly bigger than the oil and gas sector, and that has real implications to vessel productivity. I mean, these are some real technical nuances, and as we do some calculations on that with the fleet of vessels that are there today, just to show what that actually really means in terms of productivity. So it helps project planners, but it helps people who are looking to design and build vessels to understand really the technical nuances of what's needed. And we are concerned about the supply chain around mooring systems themselves, the actual manufacture, supply and marshalling of these, which may be a bottleneck for market growth, and of course vessels. Now, the substructure on which the turbine sits, I mean, that's going to float, and it's often assembled at a port or in an inshore protected area, then towed to sea, unlike a bottom fixed turbine like you see behind you, which is you go out, you put the foundation in, then you build the tower, then you build the turbine with a jack-up vessel, basically. There are other vessels, but predominantly for the turbine, certainly a jack-up. Now, those foundations, I mean, today's next generation foundations, you're talking 120 meters long when they're laid out on the ground, 2,000 plus tons. I mean, quite big. And, people are talking of going up to 3,500. A floating wind substructure, probably at the low end, will weigh from 2,500 tons up to, well over 10,000 tons, especially if it's made out of concrete. You can build them out of concrete and steel. And they'll have big footprints. They'll need about 4,000 to 5,000 square meters minimum per unit in a shipyard or in a port. or when they're being stored at a wet berth at a port. So these are big numbers, and these requirements drive large towing vessels and large ports. And then you've got these inter-array cables that connect the turbines. So that's basically your turbines. Again, like you've got two peak turbines behind you, they get connected up by an inter-array cable that puts them in an array that then gets connected to the export substation or directly to shore. Now, in a bottom fixed wind farm, they're generally static. So they're laid by cable layers that can lay a static cable that's not meant to move. In a floating wind farm, these are dynamic or flexible, actually much more familiar to those in the oil and gas subsea market. And they lend themselves to installation by subsea vessels with vertical lay systems. So, I mean, you can use traditional offshore wind cable layers, but there's the trend has been to vertical lay systems in these on the floating wind projects to date. So that's a bit of a difference. And our report on the installation market through 2035 for floating wind takes a real deep dive into the commercial and technical factors that drive this vessel demand and says what will those vessels look like and why.
I'd like to go back for a moment to a point you raised earlier, and that you mentioned you're concerned about mooring systems supply chain bottlenecks. Why?
I try and summarize it in 3 words: quantity, flexibility, size, or component size. So that's 4 words. So quantity, we're forecasting a ramp up of commercial wind farm numbers towards the end of the decade. We're at demonstration pre-commercial scale now, and the ones that are going in the water now are sort of 3-4 turbines. By the end of the decade, we'll be sort of seeing 30, 40, 50 turbine arrays. So, significantly bigger. Now, let's take an example of a typical commercial floating wind farm of 500 megawatts. And we do actually see quite a few 1,000 megawatt projects out there. Now, a 500 megawatt project, what does that translate to? That's over 34 turbines, or around 34 turbines, let's say, just assuming you go with the biggest commercially available turbines today. That's 34 turbines. That means 34 floating systems on which the turbines sit and 34 mooring systems. Now, that translates to over 100 anchors and mooring lines. Now, that doesn't actually sound a lot, but when you aggregate that across 4, 5, 6 wind farms that need those numbers, you start talking to quite a lot of mooring equipment. But then if you compare that to something like a floating production system, which has pre-laid moorings, anchors and moorings, I mean, that might have, 16, 24 mooring lines. Here we're talking 100 anchors and mooring lines. So we're talking an order of magnitude bigger. Some of them may be a bit shorter, but when you look at the actual volumes, the volumes start to get a lot bigger. And that drives vessel capacity, because your vessel capacity is generally built for floating production systems and drilling rigs. What you're asking them then to do is do bigger quantities of it. So when you've got a tight market in the oil and gas side, what that indicates there may not be the supply for the additional floating wind projects when you get to commercial. And that is a point, that there is that the floating wind projects will be competing with a buoyant oil and gas segment for the same equipment that installs vessels, which is really anchor handlers and subsea construction vessels, or subsea construction support vessels. Now, on the flexibility side, you've got well over 80 different concepts of how to sit a turbine on a foundation. So 80 or 90 floating structures. Now, they loosely are grouped into semi-subs, spars, TLPs, loosely grouped into that. But they're all a bit different. Some are box-shaped, some are cylindrical, some are made from tower and monopile components, some are concrete, some are steel. So, I mean, there's a lot of differences. And the people designing them have different views on the mooring systems, how they're tethered to the seabed. Also, ground conditions play a role, which mean that solutions are going to be different. So as a supplier, what you need is the flexibility to accommodate multiple needs. We do see that there are going to be some systems that are currently, in the short to midterm, more preferred. Well, the semi-sub, for instance, we see is more preferred, and these systems will generally be moored, we think, by conventional mooring spreads, although some systems will be single-point mooring or tendon mooring systems. But they're going to feature steel chain, spiral wire, and or fiber rope, a combination of all 3 or just one. connected to a variety of different anchors, from drag embedment to suction anchors to piles. There's no one fixed solution. It's all ground conditions related, although again, we see drag embedment in certain markets certainly being the preferred solution in the short to midterm. Now, flexibility is required to meet the various requirements. Otherwise, you might have the installation equipment that's good for one specific environment, but not for everything. And again, the flexibility around that is very important, but understanding the nuances of how that flexibility is met. Aside from the components, this one, what I've said is we've taken a deep dive into a lot of planning documents for projects to see what developers are actually planning, what they're asking permission for. Doesn't mean they're saying we are going to do this, but they're saying we are considering these options. And when you look at these, the flexibility of solutions that deploy chain, wire, and rope sizes that are amongst the largest currently available, manufactured, I mean. And these are larger than those deployed for station keeping in the oil and gas projects, and in some cases much larger. We have a case then that the vessels which were designed to accommodate the oil and gas projects and are optimal for those become suboptimal for the floating wind projects, because they may not simply have the capacity designed for that. So to try to bring an end to this long story of the detail, if you bring all those factors together, which we do in the report, against the vessel supply category that's there, because we rank and each of the large anchor handlers and subsea construction support vessels, we note that most of these vessels lack one or more of the key attributes that makes them optimal for floating wind. It doesn't mean they're not good for floating wind. They can't be used. What it means is you just need more of them because they lack the full flexibility to do everything. That means instead of one vessel, you need two vessels to do the job of one. And when you've got high utilization in the market, that basically means you're putting a strain on the market supply. And that's where we see the problem, because we see oil and gas demand quite high. Now, so that just leaves a vessel owner with three choices. And this really is what it boils down to. You either deploy these existing vessels on floating wind and oil and gas projects, and our view is that there won't be enough vessel capacity for project schedules to be accommodated. So if you want to build these projects, it just means you need more vessels. If that is your solution, to use what you've got already, we won't have enough. It's just absolutely not. You can upgrade existing vessels to accommodate the needs of floating wind. And this is technically possible. And some vessel owners and equipment makers have studied the requirements. So it is technically feasible. But if you do that and you're spending money on your vessel, you're still probably then taking away one feature or two features that makes them optimal. So you're solving one of the problems, but maybe not all of the problems, which may make them project suitable, but maybe not market suitable long term. So then you've got to question long-term investment and the risk profile around that. And then just ultimately, as I said, if you're saying that, well, we can't just deploy what we've got and we can't upgrade, or we can do that, but even if we deploy what we got and we upgrade what we got, we're not going to have enough. The equation that comes out of that is we need more vessels built.
Are we going to see a new building boom?
Well, in our opinion, that's a $12 billion question, because that's the investment hole that we see at the moment. So is the long-term conditions there for new building activity? Yes. And, as I said, roundabout, we forecast at least $12 billion or up to $12 billion. And that is required in a relatively short term in terms of decisions being made, because it takes 3 or 4 years to design and build these anchor handlers. And if you include financing and all these sorts of things, you're talking 2026, 2027. So actually, we're probably quite close to the point where companies need to be planning this. And so the conditions are there to do it. I'm certainly not advocating building these vessels on spec, because I think the right vessels are going to be significantly more expensive than some commentators would believe. Because if you actually look at the specs that are required, get these priced up by yards, they'll be in the order of magnitude of double the cost of the last big anchor handlers that were built in series that were delivered around about 2016, 2017. There was another big anchor handler delivered after, and she was quite a bit more, but not as much as these will cost because of the cost inflation. So is the market today ready to invest in that? Well, if you go and ask a OSV company, will you put up well north of $100 million for a vessel? I mean, north of probably $150 million for a vessel, and that's just for one. And you're talking to an industry that is recovering from the historic lows triggered by the low oil prices of 2014 that lasted. Well, I mean, companies are still finishing their restructurings at the moment. And you've got historic shareholders and funders and banks and insurances that have taken those quite big hits at the time. So your ability to do the deals you used to do, go to yards, get a 5% or 10% down payment, pay 90% on delivery, get very high leverage, 80-90% from a bank and financial institution, we feel is gone. That means obviously the companies need more cash and need to actually put more cash into that. So I think the conditions at the moment are challenging still. I mean, we've seen utilization rates go up in the oil and gas industry and day rates go up, but we're not seeing the new build orderings yet. They're happening in certain markets like the Middle East in the smaller sizes, but that's often backed by a state-owned oil company with long-term charters. If you get an oil and gas, an offshore wind developer coming in and committing to a long-term program because they have a long-term program of these floating wind farms, yes, we see that happening. And if you look at the bottom fixed wind industry, you will see that because of perceived shortages around the prime equipment of wind turbine installation vessels, developers are in fact engaging vessels much earlier and for much longer. We will commit to using your vessel for 5 years. Now, you can argue how firm some of those contracts are, but they're commitments that give people a lot more assurance. Now, if we move into that in the floating wind space, then I would say that that's going to create those conditions where the financing will occur and where the projects will take place for shipyards and equipment suppliers. So yes, there is building needed. Yes, I think the industry is probably quite conservative about looking at it. But quite simply, if we don't start investing, floating wind projects won't happen. And I would say, just linked to investment, it's not just investment in the steel, it's investment in people. And often I would say this is a forgotten thing. We are talking quite complex installation vessels. They're DP2 as minimum. They're involved in subsea construction work using ROVs, cranes, big anchor handling. So there's safety issues, there's productivity issues. And for that, you need experienced mariners with the time in their logbooks to show that they are competent to do these projects without damaging an asset or hurting somebody. Now, at the scale of the fleet as it is today, you've got the mariners to meet that, although there are quite a lot of reports from vessel owners talking about struggling to recruit back deck crew, even bridge crew and engine room crew of the right caliber for the jobs that we're talking about. Now, we're going to be talking about these vessels, even if the earliest you ordered a vessel tomorrow, probably the earliest you get it delivered is 4 years' time. So that's when you need your crew. So we've got another 4 years when the crews that were with those original 1970s, 80s, 90s anchor handlers are, beginning to retire or, are out the system. You've had the COVID issue, you've had the low oil and gas prices, again, competency out the industry. You've still got people in there, but it's whether, do you have enough that you can spread them all around your vessels and the operations side to hedge your risks? So we would certainly advocate for companies to be looking at the training issues that are required around there, that any investment program because the training is not just classroom training, it is man-hour training on the vessels, and that takes time.